So everything I have written here is all true. These are all true statements. If you measure throughout the year how much ice cream is sold versus number of drownings, you'll see there's a very strong positive correlation. As ice cream sales go up, drownings go up. When ice cream sales go down, drownings go down. Does that mean that eating ice cream makes people drown? Of course not. That thing your mom told you when you were 6 about not going swimming until a half an hour after eating, that's not true. There's no relationship between eating and drowning. Ice cream is not making people drown. So what's going on? What's the relationship here? Well, it's summer. As summer comes along, people are buying more ice cream because it's hot, and more people are going swimming. The more people you have in the water, the more drownings you'll have. Just because two things are related does not mean one causes the other. This is also true. Sleeping with your shoes on is very strongly correlated with waking up with a headache. Do shoes cause headaches? No, of course not. Who falls asleep with their shoes on? Drunk people, and then they wake up with a hangover. Just because two things are related does not mean one causes the other. There could be what we call a hidden variable that's causing both. The more firemen you send to a fire, the more damage is done to the house. The worse the fire is. Does that mean firemen are causing fires? No, bigger fires have more firemen. There is a very strong negative correlation between the number of hats that men wear versus global temperatures. It's a negative correlation. As global temperatures rise, men are wearing less and less hats. Are men causing global warming because they're not wearing hats? No, of course not. Just because two things are related does not mean one causes the other. No, there's no relationship whatsoever. This is just pure coincidence. People stopped wearing hats because of fashion, not because of temperature. If there's one thing I want you to get out of this class more than anything else, it's correlation does not imply causation. A lot of times you'll see some news article that says, scientists have proven that blank causes blank. That news article is 100% crap. I guarantee it. No scientist has ever said, my data proves this thing causes that thing. That's not what science does. Science finds correlations, relationships. Statistics is used to find relationships. And then maybe a biologist might come in and say, well, we think maybe this thing is causing that thing, but they would never say something definite. Correlation does not imply causation. Just because two variables are related does not mean one caused the other. We could have the cause and effect backwards. There could be a hidden variable that causes both, or it could just be a coincidence. So here are some graphs. I forget what website I got these from, but it's all about, the entire website is devoted to this concept that correlation does not imply causation. So this is per capita cheese consumption correlated with number of people that died tangled in their bed sheets. Look at that nice relationship there. They seem to go along together. It's pure coincidence. Look at the divorce rate in Maine versus the per capita consumption of margarine. Clearly, neither one of those is causing the other. It's pure coincidence that they follow the same trend lines. Number of letters in the spelling bee versus people killed by venomous spiders. Pure coincidence. Now, a growing trend in science, we're going to talk about this at the end of the semester, something called the replication crisis. We live in a society where it's publish or perish. If you work at a high-level institution, a publishing institution, you're expected to publish some certain number of papers per year, or you'll lose your tenure. It's part of your job to publish, I don't know, let's say 5 papers per year. So what people have been doing lately is they'll go out and they'll collect a whole bunch of data over maybe 200 different variables. And then they'll have their computer check variable 1 versus 2, 1 versus 3, 1 versus 75, and check all the possible combinations and see if they can find anything that looks like this. And if they find something, then they publish a paper and they say, look, we found a correlation between these two variables. It's crap. It's bad science. If you look at enough variables, you're going to see relationships that don't really exist. It's pure coincidence. And the scientific community is aware of this, and there are efforts now to stop this. It's not like it will always be a problem, but it has been a problem in the last 15, 20 years.